let's share the screen. Perfect. So what we'll do today, I think previous tackle. So what we'll do today is that we'll start with the hand size, which Trina said to see encoding stuff. So we'll start with that. I'll just keep the things open and then. Okay, so today's agenda was to discuss the partitioning and shuffling. We'll start from this partitioning and shuffling bit after we are done with the hands-on. So let's start the data. Perfect. So we have the cluster running, and in today's topic, we decided to see the concepts like label encoding and one hot encoding. So these are I'll first give you even if you know these concepts, I'll just try to explain it from my perspective, how I understand these concepts, and then we will go with the we'll try to implement it. So what happens when we have data? We have technically a couple of data types, which is like we all know that we have numbers. Numbers can be of int, double, float, big int, etc., etc. These are the type, but technically we have the numbers. Numbers can be of two categories. One would be numbers with magnitude, and there could be one number with continuous variable. So what
Keshav,
are
are you writing some
sharing?
Yeah, sharing got stopped, I guess.
Yeah.
sharing is stop? It
Yeah.
shows me that I'm sharing, but let me just share again. And there was drop, or somebody else is trying. Do you see the screen now? Hello?
Yes, we can see.
You can see, right? Okay,
But
so I was
we are
talking
only
about
able to see. Yes, now we can see.
No, we can see.
So sort of internet problem. Yeah, I'm sitting a little far from the router. I don't know if it's internet issue on my end. Let me know if you still see the drag. I mean, or is it better now? You see the Excel, right?
Yes.
We were talking about the different data types, and then initially I picked the number. The number is a category which could be of different data types, and it has it could have two different significances as well. So there could be numbers in our data which would have the magnitude, and there could be numbers which would looks like continuous variable. So I'll give the example. Like continuous variable would be like ID. So ID would look like a continuous variable. So if I would introduce an ID here, 1, 2, 3, 4, 5, like primary key, you can say. So there would be data with some ID in it. So this is a continuous variable. This is a continuous, and this is of type number, but this doesn't have any significance because model cannot learn anything from this. Still the internet problem. So is this clear now? Maybe
Yeah.
you'll have to not today. I'm not sure if unless the internet problem gets fixed.
No, we can see the Excel sheet.
You can see,
We
right?
can see.
I heard a ping that Priya was trying to
No,
join.
no, I just now it's clear.
Now it's clear. Okay,
Yeah.
so this is one type of variable in the data. The second could be of something like uh, salary. So let's say this guy has 100, this guy has 200, this guy has 300. So if there is something like this in our data set, we can understand this has a significance. This has a significance and it has a magnitude. We can easily say that ID1 has double the salary of ID4, or ID2 is getting double salary than one. So there is a relation, and you can have a multiplying factor to get to establish the significance between the two data points. That's called the magnitude. Similarly, there could be okay. This is 12. This is 13. This is 14. This is 16. Now you can tell me. I mean, is this a continuous? I mean, it looks like continuous, but let's add something like few more 07. So with A's, we what do you see? Is it a continuous variable with the magnitude? So it's something in between, we can say, right? So we if there is you can say that the ID7 is can be categorized as a small, I mean orchid, and this can be classified as senior citizen. This can be classified as adult. You can do that, but the point is with A's you need a further understanding. Otherwise, the safe side would be if you're not if you know, you can take this, decide this judiciously that you want to continue with the A's or no. Okay, so A's can have, it has the magnitude. Is this is also continuous, but when you need to further treat this based on your target decision. So whatever your prediction or classification, or uh, based on your even if you are doing the cat clustering, you you have to take a call that whether A's makes any sense to you or no. But by looking at it, you can pick to the you can choose to drop, or you can choose to modify this and then use it. That is uh, there could be two options in this. Now we'll come to the age part, but I think with number, these 2 points is established: magnitude and continuous type of variables. Similarly, we could have a data type called a string. We also call it varchar. A string could be of varchar, could be string itself is a data type, so no worries. Now this string could be of couple of different types. String could be description. String could be categorical. 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 Now categorical, if it's if this string value is categorical, in that case there could be two possibility. Either that category has the again the significance, or it doesn't have the significance. Either it's like it has the we call the point called ordinality. Ordinality. Either that categorical variable will have the ordinality, or it will not have the ordinality. Now, ordinality is similar thing what we call the magnitude in numbers. Like, can you establish a relation between two different category of the string data type? So let's take that example as well. Let's say, okay, let's complete this, and then is range. So what will you do with this? You will try to classify kid as if it belongs from let's say 5 till 13. That will be class. So you can call a kid if its age is between the bin bucket of, you can call this technique binning, or you can call this technique as bucketing. But that means like from 0 to no, not 0, let's say okay, 0 to 5 you are classifying as kinder. 5 to 5 to or 6 to 12 you classify as kid. Mm, 6 to 12. I don't know. Let's use some other demarcator. 6 12 or whatever. Let's no, we don't need to be specific. Let's classify them as in 26 onwards. You're calling young continuous citizen. So this the technique is like you are creating a bin size, and then you are using your age range. So instead of using this something like this, you have clubbed them together so that your clustering can work, even your model can work, and then you can further utilize this in a better way. 26 till let's say 40, and 40 plus you are classifying as senior citizen or something. Right? Making sense? Age was not age was a feature in your data set, but instead of using this in a continuous pattern, you try to bin it, and then you classified them as these category, and then you have used this in your data. Now, how you'll use this in further is category. That also we'll see. Now this has become a string type, so you can then apply the label encoding or one hot encoding onto this. But instead of changing this, let's pick some other string variable. Let's say let's put some description here. Description obviously won't make any sense for the model, so you will not be doing anything with this. Then there could be let's say t-shirt size. S M L XL. What we can do with this? It has if I will apply a filter on this, you'd see there's let's copy this to some other sheet. So there are we can see that including blank there are 6-7 identified categories in which the whatever, even if millions of record, it would be maximum up to 10 category. right? Making sense? Now for this, what we can do, we have two options. We can either level encode this, or we can do the one hot encoding. So how does that how is it different? Let's say if I'm doing this t-shirt size label encoding, in that case I will give this as a 0 1 2 3 4 5. I have given them numbers, and numbers has the magnitude in it. Like we can understand that if model is using this feature, instead of using it this way, it can use numbers and it can do the calculation. So typically, again, I'll talk about, let's say, decision tree or tree based model. What happens, the binary decision is taken at every steps, and to take the binary decision you calculate some coefficient, you calculate some value, you do some calculation, and calculation is always better when you have numbers. On this, it will be very difficult for me to do the calculation. So either my model will decide to drop this and won't do anything, or if it's smart, it can convert it to numbers and then use it. So level encoding has gives some edge to the models like decision tree based or random forest based algorithms. Also, it helps in the neural nets as well. Neural nets also has the calculation, and every neurons, when it's doing the calculation through the activator function, it can easily calculate the value if the feature are in numbers instead of something like this. So there is a significance in assigning a number to your categorical variables, and this has ordinality. You can see that small is little larger than extra small, medium is larger than small, large is larger than medium. So it will always be like number 3 will be greater than previous all categories. This phenomenon is called ordinality in simple terms. Clear? Okay, so now the question would come that this is level encoding, then what is one hot encoding? So let's take another example. Let's say status. And status, we can keep it like new, open, active, closed, remove, uh, pending, etc. These could be some categorical fields. Now it's not necessarily that something is closed, then it would have gone through the complete cycle. I mean, you cannot specify them technically by looking at it. So in your data set, there would be some features which would be just like which would be important, but it won't have the correlation between the previous values, or you can't just specify any magnitude to it. So in this case, in these situations, you can use the one hot encoding. So what you can do with this feature, you can create a status dot new simple strategy, and then we will see it practically. Status open, status active, status closed. Okay, now what we can do that let's drop these. Let's say for this ID, the status was new, so this will have a value called 1, and rest everything would have 0, something like this. This would have 1 here, and rest everything is 0. Should be 0 0 1, because it was active, right? then 0 0. Okay. So this phenomenon is called one-hot encoding. When you do something like this, sort of circus with your data set, not including from here. If you do something like this, that is called one-hot encoding. And when we do something like this is called label encoding. This, if you do something like this, that is called binning or bucketing. And this is a perfect variable for you, perfect number. So this was the concept. Now the question, there's two thing, there could be two questions, like when to use label encoding and when to use one hot encoding. So we understood this, that we are doing label encoding in cases if the possible variance in the data is less and it has the ordinality. And from ordinality we understood that it's extra small, small, medium, large, they are all in the sequence, they are in the increasing order of the uh, value. So even if this data will be distributed and you would have something over here, every time the Excel will signify that Excel is larger than the L or medium or medium or small. Then that's one of the criteria to do label encoding. And then we'll do label encoding if the number of possible values in this is less. It should not be like there would be 100 of t-shirt sizes. If there are hundreds of t-shirt sizes, you will try to do a binning, something like this, right? You'll club it and give it another significance, and then you can do one hot encoding or you can do label encoding, but you'll try to reduce the number of possible values in that field. So if there is a string for which you need to do label encoding, you will try to pick the columns in which the number of possible values are less. By less I mean you can take that call judiciously. I mean the things, this is the uh, machine learning model. So feature selection itself is a module in which you decide what feature can be engineered in what way. So when you are taking that call, you have to decide this. So technically your number of possible values should be less means 5 to 10 are considered as ideal numbers. More than that, you will try to do the binning first and then apply the label encoding. Okay, that's one of the option. For one hot encode, that's one of the choice or decision you will take while doing the label encoding. For one hot encoding, you will do if there are again limited numbers of values, and then those values are not in any sequence, neither in ascending or descending or related to each other. So in that case, you will do something like this. Okay, now one hot encoding is an expensive task. You are saying that you had one feature which got created into the uh, 6 different variables, and you have lots of sparsity in this. So one hot encoding, if you are doing, you have to, you'll be uh, putting pressure on the machine compute. This would be a tedious task in the sense it's compute expensive, memory expensive, same data gets exploded into number of columns. Let's imagine that if this would have thousand of different values, in that case there would be thousand different columns would be created, and then you would have some of the fields would have 1, rest everything would be 0. So one hot encoding decision is also you take if there are lesser numbers of values in that column, and then those values are not related to each other. Clear? So some benefit with one hot encoding, and then some demerit. The demerit is like you get lots of sparsity. It's a compute expensive operation. So you need to be very careful when doing the one hot encoding. But if you don't do this, then your model will not will not be able to train on this feature, because model it's better same ground rule thumb sorry same thumb rule. Model will be working better in a better way if calculation can happen on the numbers. So you have to feed the model with numerical fields with right magnitude. Clear so far? Any question?
Yeah. So
Yeah.
binning and bucketing is needed before label encoding.
If let's say this age could be like from 1 to 65, right? 65 different possible values could be in this field,
Mm-hmm.
right? So
Mm-hmm.
if you directly do the label encoding, you will have 65 values. So what's the point then? Let's say I'll just give you an example. Label binning is not always needed. Binning is only needed if you are doing a label encoding on the field which has more than 10 possible values. So
Okay.
if I'll do 3, and if I'll expand it to, let's say, these all could be the age of a person, right?
Mm.
So even if I will do the label encoding on this, I'll again be giving 0, 1, 2, 3 itself, right? What I did. So there's no point. For this field, if I'll do the label encoding there's no point, because label
Yeah.
encoding is also I'm assigning the numbers. They
Mm-hmm.
are already number, they are already continuous. So binning is needed since there are 65 different values, and none of the values is related to another one. So this looks like age can be easily classified into the 5 different buckets: kinder, kid, adult, young, and senior citizen. And then you will
Okay.
just be dealing with the 5 values. So if those those are the use case, those are the not use case, those are the features you have in your data set, then you do the binning and then you do the label encoding. So I'll do the label encoding for this 1, 2, 3, 4, 5, only 5 values in our data set.
Okay. Mm-hmm. Makes
Similarly, it
sense.
could be the zip code. Let's say you have the zip code, and you know that from this sequence to this sequence, all this zip code belongs to this county or this state. So
Mm-hmm.
you just do the binning first, state wise, and then you can use the zip code as well for your feature. But directly, if you're using zip code, it won't make any sense to the model.
Yeah. Okay. Thanks.
Clear? Okay, perfect. So now we'll go and see. Let's say label encoding and one hour encoding. And this is a okay. So the first thing would be we can do this uh, with any data set. So the first thing is that we would be seeing the data, what data we are working with. So let's download the data. So in this exercise, I can also show you another concept, which was like Parquet format. So this is the Parquet file. It has the registration ID, first name, last name, email, gender. Okay, by looking at this, we'll try to we'll do that exercise, that if it's important or it's not important. Download. Okay, so first we need to load this data. I think there was just copy this. I'll go back to my session. So let's see, we have the user data, right? So earlier we were doing the read CSV, we will do the read target. Nothing else will change. And we'll provide the path. The Spark is pretty smart. Nothing changes. So this was the file I wanted to read. Yeah. User data dot head. Okay, so it has registration date time. It has the ID, first name, last name, email, gender, IP, some credit card number, country, birthday, salary, title, comments. Okay, now see. Clearly we can say we so far what we have understood. I'll go one by one. But the first thing, ID, we saw that it's never of any importance, right? So for model training, we'll not be doing anything with the ID. Reason, it's a continuous variable. Model will never be learning anything from it. Name, definitely not of any use. Last name, not of any use. Email, no of none of our use. IP address and gender. Now, gender is a very important field. It could be like for any of the. Right now, we don't know the use case, but gender we can easily. It has only two values, so you can do both the things on gender. You can do the one hot encoding, create gender male and gender female, two columns and 1010. That's one hot encoding. Or for gender, you can also decide to do the label encoding. So because this has just two possible values, so 0 and 1. So your question, you can ask this question that why male and female doesn't have any magnitude. I mean, you cannot understand from these two possible values. But since there is only two possible values, you can give them 0, 0 and 1. So let's try this to understand gender. If it has male, female, male. Now, I said that we saw this earlier, and I said that on this you can use both level encoding and uh, one hot encoding. So let's do first the label encoding. If I do the label encoding, what will happen? It will look something like this, right? And if I'll do the one hot encoding, then it would be like gender underscore male, gender underscore female. This will be 0, this will be 1, this will be 0, this will be 1, this will be 0, this will be 0, this will be 1, 0, 1, 0, 1, 1. Now tell me, is there any difference? I can use this, right? Technically, uh, by saying this, even in the one hot encoding, we are saying that female is 0 and male is 1. Over here also we are classifying 0, 1, 0, 1. So model can learn from this as well. Model can learn from this. So especially if there is a binary nature of the variable, you can decide to do anything. Even if it's an ideal case of one hot encoding, because all these values are like they don't have the ordinality in them, but still you can decide to do. Similarly, up to three possible values or four possible values, you can do the label encoding and one hot encoding. Both are considered as safe. Believe me, up to if two is the ideal candidate, you can do anything. Three, with three different possible values also you can do. Let's say even if you introduce another gender on this, uh, mm, uh, then also you can do the label encoding. So others, you can still try to do the label encoding. This all will be so with gender you can decide to do this. IP address, with IP address, you IP address is not a field which can you which IP address and phone number are the fields which is of no importance. I mean, sorry, which has the importance, but model cannot use it directly. Model cannot because 1.197.2012 model will not understand anything from this. So for IP address, zip code, phone number, things, first preference is if it's not needed, we'll try to drop this column. But let's say phone number, zip code, and IP address is needed. In that case, you'll try to get some significance from this. So does this look like a particular subnet, like starting from 1 or starting from 218? Or so based on subnet, you can uh, create a bin, or you can create a variable, string variable, and that string variable will further be one hot encoded, but you cannot use IP address directly as it is. Credit card number, not of any importance. Even if you are doing credit card based prediction, this number is not needed. You can further have this ID or something. You can just keep this ID and then assign the credit card. But credit card number directly you can't use it. You can just give a random sequence or encrypted value or anonymized value. Credit card number, you're not supposed. But first thing is you're not supposed to use. Second thing is even if you're supposed to use, your model will not never learn anything. It will be a very much randomized and etc. number. So the only thing you can do is, like, if it's starting from 6, it could be Mastercard. Starting from 3, it could be Diners, or 5, Visa, etc. That kind of category you can create. Or if it's related, if you are doing the user specific prediction, then you can keep one of the identifier, or you can add the identifier later after the learning has happened. Country could have possible 196 values. So how to use country again becomes difficult for you, right? But for country, even if it's a 196 different specific, and you are lucky to have 196 different countries, the best you can do is one hot encoding, but there would be a 196 column will be created. Country India, country Russia, country Canada. So you will just make it sequential, something like ID, and then use it. So it's a country is needed, as well as we can't do much. We can't do one hot encoding because it will become compute expensive. 196 column will be unnecessarily added to your model. So you will, over here you will again, if it's possible for you to convert this in a geo, like Asia Pacific or Middle East, or North America, South America, etc., and you can work with that, that's great. Otherwise, you can just label encode it 123 or something, give some ID. Birthday, not of any significance. If you want, you can birthday, you can calculate the age. From the age, you can calculate you can bin the age category, and then you can label encode it. Salary, you can use as it is. Titles, you can label encode, because it will have maximum uh, possibility. But we don't have to detect. You can see that how many titles uh, are in that data set. If let's say if it's 100 plus titles, only label encoding you can do. If it's, let's say, less number of titles, then you can do one hot encoding. But title is needed, because based on the title you can try to determine the salary, or some of the other fields can be correlated. Comments of no use. Okay, so these things we have seen. Now now coming to the one field which I have left intentionally was the date time, because date time in itself is also a complex field, around which you have to do lots of, you can do lots of things, but you have to decide what is needed and what is not. Let's say you're doing the forecasting or time series prediction. In that case, you need the continuous time, and then you can use the individual component of that time. Date time, like year, month, date you can ignore. You can go week wise, uh, or hour of the day you can use, like this is morning, this is evening, this is noon, this is midnight, etc. You can you can split this date time into 5 to 6 different columns. If I'll just copy this, which I'm not able to, but let's say if there is a date time in your field, date time will be further split into year, quarter, month, week, hour of the day. These once you will split the date time into these possible values, you can use because year will have a number, and it's ordinal. Quarter, Q1, Q2, Q3, Q4, maximum 3 to 4 quarters in a 4 quarters in a year. Month, 12 possible values. Week, uh, if it's a week of the month, then 0, 1, 2, 3, 4. If it's a week of the year, it could have 256 or whatever number of week. 50, say 57 week or something. Hour of the day, 4, 5 categories. So with daytime, you have these many possibility to do the feature engineering. Clear? So technically, we have covered these all possible type of data types. You can further do a read and etc. But we will continue. If you have any question, you can ask. Otherwise, we will continue to modify these variables. Any questions?
No, no, Keshav.
Perfect. So the first thing is we can let's check the shape of this. If we can do something with this data itself. Sorry. What's the what was that? Describe was there? Keep forgetting these. It was beautifully showing this, right? I I want to see the stats. This is data break, and this is Python. In Python, no, but it's a Spark data frame, right? Not Pandas. Pandas, we have the summary. In this, does anyone remember what was earlier we have used to see the count, max, min, and etc. No. Somebody. Okay, let's search it. Spark data frame. Somebody. Data frame describe. Both are there, but none of these are working. Data frame dot summary. Data frame dot summary. We didn't try summary. Summary. Summary and descriptive. Describe and so. Yeah, this is what I wanted to see. Describe and then so. Describe and then show. Okay, something like this. So this is still didn't align it perfectly. I don't know why it didn't align it perfectly.
Keshav, we are not able to see what you are typing.
You're not able to see the screen
Able to see the screen, but it seems constant, stagnant.
for everyone, right?
Yeah.
Yes.
I'm sharing it again. Yeah, just let me know if you ever see that problem. Or if the screen gets freeze. Actually, there was a storm here yesterday. From last 3 days, it was a storm, heavy rain. Internet was like it's flipping and it's very disturbing from last 2 days. Now can you see?
Yes.
So till what point? Till these points you have seen, right? All these date, time, and
Yeah.
etc.
Yes.
Till these points, it's clear, right? Okay, perfect.
Yes.
I don't have to go back that far. So what I was trying to do. So now this is the one representation of the data in which we are seeing the data itself. The other representation of the data is the statistical representation. The statistical representation is that every column wise, we are trying to see what's the dispersion of those individual columns, how the data is dispersed among the complete. I mean, let's say if there are thousands of rows, how does that look like? So there are thousands of records. Okay, out of thousand of records, the minimum value is, so this is a continuous variable, right? ID. So it's starting from one and ending from thousand. So we can see that this has a high variance. Continuous. This is a continuous variable. Okay, for name and all, not doesn't make any sense. Email we decided to drop. For gender, there are thousand values. There's no null. Technically it should show few more stuff. Let me do one thing, because what I wanted to show you guys, it's still not. I wanted to show you the variant and how based on the variance you can take that call. Install pandas. Okay, then I will read this user D. Um, First import this guy. It has returned the packet. Thank God. That's it. What happened to the file? The file is there, right? It's connecting. CHG. CHG. Let's do. Read. So in this, what all we are saying, the standard deviation 25%, 50%, and 75% max. Okay, so they are still not giving us the variance which we wanted to see. So let's say in this data set, it is showing latitude, longitude, all these have values, and min, max, and etc. values. So let's import one more profiling library, pandas profiling. All I don't know for this profiling, do I need to pass the data frame itself? So pp dot, what do we have? Page codec describe file report. Df we have created on top was CHT. See, these are the few parameters which are very important, like standard deviation, skewness, correlation, missing values. So seeing the data descriptive in a descriptive way is what we can see here, right? This is a descriptive way. What is the count? What is the min max, and etc. So with this, we are seeing the central tendency of the data, what we call, like these are all centralized information. So most of it doesn't make any sense. It would make sense for some of the numerical fields only. So uh, for which one this is making sense? Let's see. Population 3,000 total rooms. Min is this, no sense. Minimum is six rooms. Maximum is 30,000, which is no sense. Uh, Total bedrooms, 2 bedrooms and 5,000 bedroom, no sense. Standard deviation is also like 415, no sense. Median income, and yeah, so I think they have already calculated the median income. That's why this field is making sense, that the minimum is this and maximum is this, and within this range. So if you will plot this, then also you will see the uh, right distribution of this. Median house values is also making sense. Maximum is this and minimum is this. So the value of the house is like 20K, varying till 500K. So with this describe and this describe, they are all doing the same thing. They are showing you the central tendency of the data. What I am interested in right now is the dispersion of the data. When I say dispersion, I want to know how the data is distributed, like how many nulls it has, whether this data is skewed or not. Let's say all the let's say gender, and then I'm saying that in that gender field, if all the fields are male, so that means it's a skewed data, right? We don't have uh, female value in that. So in that case, even if I'll use that column to train my model will not learn anything. It has no value. There's no uh, different values. It's all male. So I can drop that column. So you have to understand these important points, which is like most frequent values. You have to understand the correlation of them and the missing values and etc. So how to get this? There is a good library called Pandas Profiling, and it generates a very beautiful reports. So this I was trying to do, which we need to do on directly on cxt.pro. Data frame is already created. That so let's see once the usage of this, how they are using it. Pip install pandas profiling. Pip install is done. Conda setup install pandas profiling. Okay, data frame is created. Profile report data frame, something like this. XT. Profile report is not defined. Profile report is it import profile report. Okay. So plot histogram is an expected mandatory field. Cat got an accepted join access. Is the problem. Explorative true. concat got unexpected keyword zone access. PD concat indexes access. We need to provide this. Data frame is created, and then pandas. We only use the first 10,000 data points. Properly put DF sample this no, minimal to saying something with the join access. Does this guy has this on conclusion somewhere? Dictionary to data frame. Okay. Uh, HTT equals to pd dot frame. Pandas profiling not compatible with Pandas version this. Okay. Some sort of just yeah. So this was the point I was saying, that the TF describe of Pandas is great, but little more exploratory data analysis you can do with the Pandas profiling, and it's a great tool. Some version conflicts. It's saying that it has some version conflicts. We'll try to just fix it. Just mm, simple, fast. Encoding. Okay, so pip show check Pandas profiling version. What version we have? Pandas profiling 1.4, and this guy has 2.8. Let's do it with the random. If it's still not working, then it shows that it's a problem with the version. It's still a problem with the version we have on the collab, and but we can use here as well, right? Pandas PD. We need the CSV file. Let's load one CSV and then try. When we read this Parquet, it's not able to read load one CSV. Create table. I'm just loading some data which worked earlier. Let's see if this works out. Address would be true and infer schema should be true. This again. Okay. Now let's install pandas profiling. Okay. TF2 equals to get first info from pandas. TF2 object of type data frame has no, and there's a different problem over here. I'll just do this. Yeah, this still has a problem. Okay, so uh, we have wasted some time, and this is not working. Uh, it should have worked. We could have seen a couple of more stuff. Just give it. Let's Pandas do this. Okay, we will continue to try this, and we'll move to the one hot encoding stuff. Okay, so in this we had the user data. User data is still available, right? Let's load everything again. Okay, so describe. Okay, so we'll go into the proper workflow of the machine learning. So the thing with here is the describe. Along with the describe, we'll also see the D types. D types will give us that what data D types. after we split the user data into training and test, and on data, train data, will try to do the one-hot encoding. What is this? Okay, so we have ID string of the thing is. So now the first step, as we know that we need the train df and we need the test df, and let me know if you have any questions in this flow. We can explain it, but right now I'm just continuing with the first step, which is like you are randomizing your data set on. So you create a random split of 80-20 or 60-40, anything like that. So random split, and then I'll give the percentage. So we'll create the 80% and then 20%. So this will split our data set. Okay, now one more thing, it has created two data set, but let me know if you are aware of this concept, why we provide seed and etc. But there is a 42, which is like a magic number. So every time this data will be split into 80 and 20, the right 80% will go into the one split and 20% will go into the another split. And for that randomization, we provide a seed value. So seed 22, technically it doesn't have much significance, but I mean technically there is no definition why 42. You can use 0, 1, 2, 3, anything, but the point is 42 is like an ideal number picked for your random split. So you provide a seed, and then every time this split will be created, this 20%, let's say 1 to 20 has gone to the test data. Every time 1 to 20 will go into the test data, so that your data set won't get mixed up, because the data which you have used for the training, you will not be using that for your testing stuff. Let me know if that's clear. Now we'll move to the concept of one-hot encoding. So how the one-hot encoding happens is that we see this, right? For all possible values, we create the first thing we do, we create that many columns, and then we do this. So this is the string indexing. This technique, like this is called string indexing in Spark. And so I'm using one-hot encoding technique of Spark. There are multiple ways you can do it. You can do it in the Pandas. You can do it in You can do it in the scikit sklearn preprocessing, quick transform, one-hot encoding. So in label encoding and the one-hot encoding is available in sklearn library. You can use that, or you can also use the Spark. So both in sklearn it's pretty simple. It's just a one-line command. But in Spark, it's a two-step process. First step process is a string indexer called a string indexer. Second step is called one-hot encoding. So this providing these values, which is a case statement that you are checking if the value is new, then providing 1. Otherwise, else you are providing 0. So this is like if-else condition. You can call it if-else condition, or you can call it a case statement. So string indexing creates the number of columns for all the possible values, and one-hot encoding does the case statement for your 0, 1, 0, 1, 0, 1. Clear? Now I'm not using the sklearn. We'll also use the sklearn. We can see that. But now first let's start with the string indexer. So we will import it. It's available in the PySpark. So I'm using the Spark version of it, and it's features. Even in the sklearn also it's available as a pre-processing feature. So string indexer and one-hot encoder. These two values we will use. Now in this, we'll first see how many categorical columns do we have. So for that, we'll apply a for loop. We'll see among all the data types what we have, and then we'll traverse on it. So if the data type equals to string, that means it's a categorical field. So let's just do this first step. Categorical columns, and for all the fields we have, data type in which one? I think this one, user types. So in this, we are taking the field and all the data types that we have, and then what we need to do, if the data type is a string, if the data type is of string category. Okay, let's just check if it runs. It found some problem. PySpark. Okay, PySpark. Okay, so I don't think we would be able to print it. Categorical calls. The type. No, it's a list. So I mean, categorical column has the list of all these columns, which was of string type: first name, last name, email, sender. So I've collected all those fields which were of string types. Similarly, we can also collect the numerical field, but we are one not in. Then we'll apply the string indexer on this input column. So but there's one more thing. You have to create the columns first, right? So let's create an index of that columns, and index columns would be so we will just know how to append it. We need to append that name, right? So let's append it with index, whatever the index. So it will say that 0, 1, 2. Instead of like how we did status open. So we took the status from this and then we appended this. So instead of doing this, we are just doing is S0, S1, S2, S3, like that. Okay. For X in categorical columns. This one for all the columns that we have. So this will create all the possible not S, this is X, right? And then the OHE same thing. We will append it with the, instead of index, we'll append it with the okay. Let's run if it's running. Perfect. So far it's good. Now we will create a string indexer, and after seeing the result, maybe it will be clear. But now technically we are doing something like this. So just bear with me. String indexer, and then string indexer takes what all? Takes input calls, and our input calls are this one. It will take the out. It also takes the output calls, and output calls are this one. What else it takes? Handle invalid. String order type on takes string order type. Input call, output call. This takes, I think, we can just skip it. Running. Okay, perfect. OHE encoder. First step was to do the string indexing. Second step is to do one hot encoder. One hot encoder is also a class which takes the input calls, I guess, and output calls. Yeah. Input calls is this one for one hot encoding, and output calls are this one, OHE calls. Perfect. Let's try to print and see if it's also printing. It's saying categorical calls is blank. If categorical calls are blank, the other calls would also be blank, right? The doubt. Okay, this is also blank. So why is this blank? We have user data types. So for all the field and data type in this one, if the data type is a string, bring it into this list.
Okay, sure.
Go ahead.
Yeah, so string is case sensitive. So you have written capital S, I think instead of capital S, you should write a small s.
Yeah, correct. Yeah. So this was the problem. This string was the incorrectly mentioned. Okay, so now we got the value for our categorical calls. Let's see in the index calls we have created. So see for all those columns we have created with the index, first name, last name, email index, gender index, and for OHE calls we have created the similar columns with the OHE calls. You can use your pattern here. What you want to append, but I was appending index and OHE. Now the point is we have created the columns. We will do there's another concept called uh, in Spark, it's called the vector assembler. So we need to give the numeric values for that, and let's see. But I'm sorry. Let me see. The vector is what I'm not remembering is vector assembler is needed for, sorry, wait, this concept, let me just clear. Vector assembler PySpark. Same thing, input output calls a feature and multiplies multiple columns into a vector column. From parameters. No, but my question is it needed for us? So this we have done. Vector we do not distinguish if your data have all numeric values, and for us it was not the case. It was string values. It create import schemas data. So string indexer index. Okay, so we have it's saying that we can fit, and then this is done. df.1 encoder and transform the df. But gender vector we have not created, right? This is the gender vector. 1 hot encoder. Okay, this one. I think we have the values. So let's do one thing. We'll try to create the features, and then we'll club all the features up in on which column shall we can we predict? Let's say on salary. Let's go with the salary. Um we'll predict on salary. So same thing, ML features, and we will get the vector assembler. So our target feature is target variable is the salary we said. So let's create the target call, and same way how we have created this. But in this case, that data type is which one? The data type is double. Okay. Data type is double, and field name is field. Data type is double. Salary. Salary is of this is not needed. Now we had two OHE and then this target call. So with OHE and target calls, we will create a assembler input. Assembler input is OHE out calls, OHE calls as target call. Target call has salary, perfect, and assembler input should have everything. Okay, it has everything, and then vector assembler is fine. I mean, vector assembly is anyways not a list. Now we can do the now we can decide to do the linear regression. So it's now our features are created. Perfect. The last thing we will do, we'll just import our model, and at least the basic exercise will complete. A regression model, import linear regression. We'll also try to do the decision tree. Yeah, if we get time. And linear regression, we have what it takes label column, label, sorry, label calls, and the label column is that target columns, right? So that's for us it's salary. And feature calls, the features are the features that we created. Perfect. So our model is now created. The next step is like you can do this coding and etc. So the next step is we can try to score this by using the evaluator. So let's also we will try that. But before that, I will show you the another way to do the feature encoding, which is sorry, label encoding in scalar. This also let's try. So this is pretty simple. You will call this label encoder fit and transfer, and you will call a fit method preprocessing label encoder fit and then transform. So that's all we have to do. Fit or fit transform. Let's see the one hot and coding using SK learn. This is also using a very basic Excel. So label encoder, fit transform, and then the values. Nothing much. He has the data, and then on all the values, possible values, he is calling a fit transform method. That's all. If you want, you guys can try this. It has label encode one hot encoding technique using all these different methodology. But now, which we have seen, the Spark one, this gives you flexibility to work on the huge data set using the Spark methods. So in the distributed processing, sklearn and all, except TensorFlow, rest, where did that go? Except TensorFlow, rest, others will not be distributed. TensorFlow is the only distributed machine learning algorithm like Spark. So Spark and TensorFlow, one hot encoding, it does the same thing. One hot inputs and length of that vocab. Length is mean like how many columns needs to be created, and then it creates. This is also pretty simple. So you can try this. I will send you the link. Now we can move to the other subjects. So where is that? So Priya, are you still outside, or we have Priya here?
Yeah, sorry, Keshav, what?
Oh no, I saw this message of yours. Please
No, no,
accept.
no, no, no. That was long.
All right. So couple of practical things we have seen. Now there was one thing, the pandas profiling thing was pending. Let's just try to run that again in a virtual environment. So I think on my local. Okay, so this guy has failed. Let's do let's create a virtual environment. uh, just a second, I'll just open a recent one. Project, don't save. What I will do, pandas profiling. So I'm not doing permission denied. Wait. I'm just trying again the pandas profiling thing one last time, and we'll see if that works or it doesn't. Done loading configuration. Okay, now can you create a virtual environment for me? Okay, so the virtual environment is created and activated. Now I will go and see what version of pandas and pandas profiling are needed to get this done. Google pandas incompatible, compatible pandas profiling. Now, you um, so he was saying some specific versions. I don't know why it's taking so long. Okay, so by the time it's taking time, I have something for you to show. Let's discuss that instead of waiting for the time. Uh, this will. Okay, so it's a very beautiful illustration of the use case called decision tree. So decision tree, we know. I mean, first I will set the context. That decision tree we know it's a split. You also want to sign in. So for every feature, let's say even if this was our feature, if this is a data set on which we are trying to learn, or this is a data or any sort of data set, how decision tree will work. Decision tree will see the data, and then it picks the root level of the split. So first thing it decides. How it decide for that Pandas profiling was important, but at the root level, it will decide. Let's say it's doing a split on gender. So gender is the ideal fit, right? It has two possible values, male and as male and female. So it can just split this way. This is, let's say, female. This is male, and then on male, it gets further split into the titles. Like we saw the titles. uh, this get further split into some other category. So at every node in decision tree, it tries to split that into uh, two instances, and this tree keeps on growing. This can further grow. This can further grow, and then at a level where you decide to prune it. So you know that, let's say you were using 100 features. The data will start coming this way, and then you will finally see your things getting predicted. So this is one tree which is decisive in itself. So what happens in decision tree is that the top level root is decided, the further split is decided, and those splits are decided based on the Gini coefficient. There is a formula. So most of the decision tree calculate the Gini coefficient at every split, and then creates the further leaves. So we call it leaves. So this is one tree structure. It has further optimization of gradient descent. So some concept which since this is not ML thing, but we are just uh, trying to cover that based on the gradient descent, it will optimize this structure, where to prune, how many leaves it can create, how many branches it can create, etc. Then if you are using the random forest, in random forest, what random forest will do, it will try to use every other feature at the root level and then create a tree. So there would be some of the trees which will not be detecting anything. So there would be a lot of uh, weak trees which will be put together and then give you a recommendation. So 100 of random trees are created, and we are calling it random because this particular piece is not decided in random forest. Every tree would have different feature at the root level, but in decision tree your algorithm and everything decides that what would be the optimal way to start, and at every split it decides that columns with the importance. So in decision tree you create one decision tree which is enough to take the decision, and you try to prune and optimize this tree. Instead, random forest, you create hundreds of trees and hundreds of trees accuracy put together, and then you get a final result. That's how it differs. Now, I think this concept will get further solidified by looking at this. So on this, what he's doing is let's say you had to determine whether a home in San Francisco or in New York. Uh, in machine learning, categorizing data points is a classification task. San Francisco is relatively hilly, and the elevation of the home would be good way to distinguish the two cities. Like San Francisco is hilly, so hilly is an important parameter. He's saying based on the home elevation point to the right, you could argue that the home above 73 meters could be classified as one San Francisco. Okay, so the okay, so these many feet, these many feet of house, you can classify them as in the San Francisco, and if it's a uh, of this average height in New York. So green color would be used for all San Francisco prediction, and blues for New York. Let's go. Let's add some nuances, other features, and every features he will give the importance. So see. Now square feet wise the areas. There's three uh, New York. The square feet. I mean the height. This is the height, and this is like the per square feet. So most of the houses in San Francisco, you're seeing that the height is more, but the breadth or the square feet area is less. But in New York, something is like it's the height is less because it's not hilly, and etc. So it's at every nuance, it's trying to add a feature sets. Elevation, top level, year built, bathroom, bedrooms, price, square feet, and price per square feet. Finding the boundaries. So you can read this, but and at the end you'll get to see that how uh, the decision tree works. So it first picked the elevation as you're at the root level. From the elevation at the root level, it did a two split price and price square feet. Then it further did a split on year built and price square feet, and etc. 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 So see, your tree is growing, and your decision tree is created. It will look something like that. So this is what will happen with your features as well, and this would be the shape of your model. So let's say when you will be testing with the test data, this is how you will see the results. So your data is coming, and I think it has very well visualization. You could see that this particular data points is following what path, and then see, this is the training accuracy. Now if you are testing this further, so this is how the decision tree based model detects or predict your output. So I'll share this link as well. Have a read. You'll have some questions around overfitting or boundaries or etc. If you'll see this, but pictorially this will make enough sense for you to understand the decision tree. And in the next class, in the next maybe tomorrow, today we have done the linear regression, which for that also I have just uh, fit that feature into the linear regression. But we further have to do the evaluation and test it with the test data. So two things is pending on this. The first thing we will do that we'll create the model by on this LR. We'll try to fit the train data set, and training accuracy we will get, which is where did that go? Which is this thing. Training accuracy we'll try to first figure out in the linear regression. Then once the training data set is fed, we will evaluate it with our test data set, and we'll also try to calculate MSE or root mean square error for our model, so we can understand that how it's what's the accuracy of our model. So we'll write 3-4 more steps here, and then we'll move to the decision tree. For decision tree also, I mean, if we'll continue with the same features, the only thing we'll change that over here we'll use the decision tree, and then the fit and the evaluation and everything will continue the same. So go through this, and we'll see this in detail. We'll cover this practically tomorrow. Not encoding, and this one here. On that note, I'm not sure even if this guy is installed, it's still throwing the error. I'll also try to keep this pandas profiling ready so that you could see that importance of all the feature. So feature selection and feature importance is something also we'll try to cover tomorrow. So again, that would be a hands-on session. If you want to do the hands-on, that's fine. Otherwise, if you think that we need to cover that complete the Spark, we can also do that. Let me know how you want to take the tomorrow's class, and I will plan it accordingly.
Okay, Keshav.
Okay. So more hands-on or more theoretical?
For this week, let's complete this thing only, hands-on part, and then for the next week we can again continue with Spark.
Okay. Fair enough. So on that note, this would be all for the day, and see you all tomorrow, same time.
Thank you, Keshav. Thank you.
Yeah, thank you.
Okay.
Thank you, Keshav.
All right then. Thank you. I'll keep it more organized for tomorrow. Chalo then. See you. Goodbye. Take care.